Day 18 of cracking 500 AI in data science interview questions challenge. 5 questions a day, 100 days. If you are new here, don't forget to check out the first 17 days in the playlist. You might have missed some key questions that will be important in cracking your next interview. What is the difference between correlation and causation? Just because two trends rise together doesn't mean one caused the other. Crop top sales and global warming are both up, but I'm not blaming fashion for the heat wave. Correlation is a statistical relationship between two variables. When one changes, the other tends to change too. Causation means one variable actually causes the change in the other. For example, if there's a strong correlation between hours studied and test scores, it suggests a relationship, but causation implies that studying more directly leads to higher scores. To establish causation, you typically need controlled experiments, not just data analysis. Understanding the difference is critical in data science. Models built on false causality can make poor predictions and bad business decisions. When should you use precision over accuracy? In medicine, would you rather miss a cancer case or falsely flag someone healthy? Accuracy measures overall correctness, but in imbalanced data sets, it can be misleading. Precision focuses on the quality of positive predictions. How many predicted positives were actually correct? Use precision when false positives are costly. For example, in email spam filters, don't mark real emails as spam. In medical diagnosis, avoid falsely diagnosing healthy patients. Use recall instead if false negatives are worse. For example, in missing actual cancer cases, the F1 score balances both when you care about precision and recall. Describe a time when your model underperformed. What did you do? Sometimes your model is not wrong, it is just misunderstood the problem. In one project predicting customer churn, our initial model had good accuracy but poor recall. It missed many actual churners. I dug deeper and found class imbalance, few churners in the data set. Irrelevant features were adding noise. Seasonal patterns were ignored. So I used more to oversample minority classes. And I performed feature selection with mutual information. And I additionally added time based features like months since lost interaction. The recall improved significantly. Sometimes fixing performance is not about new algorithms, but better data understanding. How do you scale features using standard scalar and Scikit-Learn? Models like SVMs and KNN don't care if your data is in kilometers or millimeters. They care about consistency. So here we have two numerical features with different scales. Models like SVM, KNN, or logistic regression are sensitive to this. So using standard scalar, we can transform data to have mean as 0 and standard deviation as 1. Using fit transform here, first learns the scaling parameters, then applies them. Resulting values are Z scores, helping models converge faster and improving accuracy. How do you remove outliers using the interquartile range method? Outliers are like plot twists. They may be exciting, but too many will ruin the story. Here we are suspecting that 1 million is an outlier. Quartile 1 is the 25th percentile and quartile 3 is 75th. So, the formula for interquartile range is finding the difference between third quartile and first quartile, which gives us the middle 50% range. Here, we are filtering out values that lie between 1.5 into interquartile range, which means from first quartile to third quartile. This is a common technique to clean data before modeling. You could have a million rows, but without understanding the domain, you are just modeling noise. Here is your day 18 dose of insight. Always take time to talk to domain experts. At least read research papers. Understand how features are generated, what variables actually mean, and what a good prediction looks like in business terms. Context turns your model from a math model into a decision making weapon.